Hey guys, today we're going to be talking about composition of functions. We'll start off with a few definitions. So let f and g be two functions denoted as f composed with g. So the symbol for composition is this little open circle. Don't confuse it with multiplication. We're not going to be multiplying it today. It's read as f composed with g. You can rewrite f composed with g's to just be f of g of x. So notice the first letter is on the outside and the second letter is on the inside. So I'll start with some examples. You can do composition with two or more functions. So we'll start with two and then work our way up to three functions, okay? So we have f of x, which is 2x squared minus x plus 4. G of x is 4x plus 1. And h of x is e to the power of x. So the first thing I'll do with the first problem, which is telling me to do f composed with g, is to rewrite it as f of g of x. Okay, so now we have f of g of x, and what we're going to be doing here is you always start with the middle and you work your way outward. So in the middle, I see g of x, and I know the equation for g of x is 4x plus 1. So I'm actually just going to rewrite this and put 4x plus 1 instead of g of x. Okay, because g of x is equal to 4x plus 1. All right. Now, usually behind this is always f of x. You usually always have f of x, which represents the x values in the letter in front. So let's say I had told you to find f of 5. You would know that x would be equal to 5, and everywhere you see an x, you're going to go in there and put in a 5. Okay? But instead of a number and instead of x, we have 4x plus 1. So everywhere that we have an x in the function of f, and we know we have to go to f because the f is in the front. So go to the f function, and where you see an x, you're going to put in 4x plus 1. So that would look like 2 parentheses 4x plus 1 squared minus 4x plus 1 plus 4. Okay, so again, this is the same as this function, which is f of x. It's still 2x squared minus x plus 4, but 4x plus 1 is now where it used to just be x, okay, because that's our new x value that we're plugging in. And then from here, you're just going to simplify using algebra. So you got to follow PEMDAS. So if you follow PEMDAS, parentheses comes first. We have no like terms that we can add. We can't simplify that anymore. So it just stays as 4x plus 1. The next step in PEMDAS is exponents. We do have an exponent of 2. So we're going to do 4x plus 1. All that means is that you have two factors being multiplied by itself. So it's really just 4x plus 1 times 4x plus 1. And then everything else is the same, minus 4x plus 1 plus 4. Okay, so all I've done is take the 4x plus 1 squared, and I have written those factors out 2 times. And now to multiply two binomials, you can use the box method. You can also use FOIL. If you prefer to use FOIL, we get the same answer in the end. So our two factors are 4x plus 1 and 4x plus 1, okay? So 4x times 4x is 16x squared. 4x times 1 is 4x, and 1 times 1 is 1. You have like terms here to add, so 4x plus 4x is 8x. So we're going to come back here and do 2 times 16x squared plus 8x plus 1. Minus 4x plus 1 plus 4. Okay, so all I've done, I've rewritten these two factors like this, but everything else I just brought it down because we haven't touched it yet. The next step here is going to be to distribute. So you're going to distribute the 2, and you're also going to distribute the negative. So we're going to have 2 times 16, which is 32x squared. 2 times 8 is positive 16x, and 2 times 1 is 2. Distribute the negative, you get negative 4x minus 1, and then we still got that plus 4 on the end. Okay, your next step is going to be to combine your like terms. So we don't have any other x squareds. So you're going to bring down the 32x squared. you do have a 16x minus a 4x, that is a positive 12x. And then you have constant numbers, so I'm going to put those in squares. So 2 minus 1 is 1, and 1 plus 4 is 5. So our final answer is this, 32x squared plus 12x plus 5. So to recap, we put the function of g into the function of f everywhere there was an x, and then we just simplified it using PEMDAS. Okay, let's try another one, g of f of x. So I'll start by rewriting. Oops, I don't know why I put g in there. Okay, g of f of x. So notice the first letter is on the front, the inside letter is on the inside. And just like before, your inside is where you're going to start. So you start with replacing the function of f of x with what it's equal to, which is 2x squared minus x plus 4. Okay. So again, we have that here in the question, that f of x was 2x squared minus x plus 4. And on the inside, we had f of x, which again is 2x minus x plus 4. Okay, now we're going to put all of this into the function of g. Okay, we know g because it says g in the front. So I'm going to go to g, and everywhere I see an x, which is only in one location, I'm going to plug in x squared minus x plus 4. So that'll look like 4 times 2x squared minus x plus 4, and then plus 1. Okay, so we have g of x, which is here. So it's still 4x plus 1. It's still the same equation, except that our x is now a little bit longer because we're putting in the equation of f. And from here, you're going to distribute again, just like we did before. So 4 times 2, you get 8x squared minus 4x plus 16 plus 1. And then you combine your like terms. So you get 8x squared minus 4x plus 17. Okay, for our final answer. Let's try another one. F composed with h can be rewritten as f of h of x. And inside of h of x, you're going to put in the equation of h of x, which is e to the power of x. Okay, so again, on the inside, you replaced h of x with the equation of which is e to the power of x. Now that e to the power of x, we're going to plug it into the function of f. So we're going to go to f, and everywhere I see an x, which is here and here, I'm going to put in e to the power of x. Okay, so that'll be 2 parentheses e to the power of x squared minus e to the power of x plus 4. If you remember your law of exponents, when you have a power raised to another power, you're going to multiply those numbers. So this simplifies to 2 times x minus e to the power of x plus 4. And this is the final answer. Let's try another one. H composed with g. I'll rewrite that as h of g of x. Inside of h, I'm going to write the equation of g, which is 4x plus 1. And that x, I'm going to put it into the equation of h, which is e to the power of x. But instead of just x, I'm going to write 4x plus 1. Okay, and that is the final answer. Okay, so now let's try a composition with 3 functions. So here we have f composed with g composed with h of 0, or we can just say f of g of h of 0. Okay, I'm going to do f of g of h of 0. And this time we're plugging in, instead of an x, we're evaluating at 0. So notice that all of these had x, 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 okay? But this one has a 0, so it's going to be different. When you have an x, you're going to get an equation as your answer, and when you have a number, you're going to get a number answer, Okay, so just like before, we're going to start with the inside. So on the very inside, I see h of 0. Okay, that's telling me that x equals 0 for the h function, because that's the first letter on the inside. So I'm going to go to the h equation, and where x is, I'm going to plug in a 0. So that's going to be e to the power of 0. Okay, so again, on the inside, we have h of 0. H of x is equal to e to the power of x, but x is 0. So everywhere you see as x, you're going to type, not type, you're going to write a 0. Okay, so now e to the power of 0, what is that? E to the power of 0 is equal to 1. Anything to the power of 0 is 1. So we're going to come back here, and I'm going to write f of g of 1. Because e to the power of 0 is 1, so we can simplify that. Okay, the next step I'm going to do is plug 1 into g. So in g, I'm going to put x equals 1. And remember, g was 4 times x, but now it'll be 4 times 1 plus 1. Okay, 4 times 1 is 4, and 4 plus 1 is 5. So the next step will be to do f of 5. So basically, whatever answer you get previously is going to be used for the next step. So the next step is that x is 5 for the function of f. So in f, which is here, everywhere you see an x, I'm going to plug in the number 5. So 2 times 5 squared minus 5 plus 4. Okay. So PEMDAS says exponents first. So we have 2 times 25, and then minus 5 plus 4, which is negative 1, which equals 2 times 25 is 50, and 50 minus 1, which is 49. So our final answer is 49. Okay. So again, when you have a number that you're plugging in, you're going to end up with an answer that is a number as well. But if you're plugging in an x, you're going to end up with an equation. All right, let's try some more examples. So let's change f and g. So now f of x is x squared minus 5, and g of x is the square root of x plus 1. And they want us to find f of g of x and g of f of x. So I'll start by writing the equation of g, since g is on the inside. So I'll do the square root of x plus 1 inside of f. So again, it's usually f of x. So that means that all of this is going to go into the x value of f. And make sure you're using parentheses. So x squared minus 5. Now if you remember from algebra, the square root cancels out with the square. So you're left with x plus 1 minus 5. Okay, so in conclusion, f of g of x is equal to x minus 4, okay? Because plus 1 minus 5 is negative 4. Now, it also says find the domain. It's important to know that whatever domain you're putting into, so the original domain of g of x that's being plugged into f is going to carry over. So even though this is a linear function that is, the domain is all real numbers, and this domain is also all real numbers, this one has a restriction, and that restriction will also apply when you plug it into f. So to figure out the domain, what I want us to do is actually graph this function right before we simplified anything. Immediately after you plug in, that's what I want you to graph. So open up a new graph, and we're going to do the square root of x plus 1 squared minus 5. Okay, and you see that the graph doesn't go all the way down, so we can pull up the table and see where it starts. So it starts at negative 1, because you can see at negative 2 and everywhere above that is undefined. So a negative 1 is a defined point, so it'll be negative 1 with a bracket, and it goes on to infinity, as you can see. Okay, so the domain is bracket -1 to infinity. And this is the final answer. Okay, for the next one, we're going to find g of f of x. So we're going to be plugging f of x in the middle. So we have g of f of x, which is x squared minus 5. And that's what we're going to plug into g. So it'll be the square root of x squared minus 5 plus 1. Okay, so you can see that these two are exactly the same, except that the x's have been replaced with x squared minus 5. And then we just have to simplify. We actually don't need those parentheses under the square root, so we can just rewrite it as x squared minus 5 plus 1. We can rewrite it because there's no like terms, there's nothing for us to combine or anything. So, and then from here, we can get the final answer. So g of f of x is equal to the square root of x squared minus 4, because -5 plus 1 is -4. And then we can find the domain. So we're going to graph it. So the square root of x squared minus 5 plus 1. Okay, and then you can see that the graph goes from -infinity. Let's pull up the table to see what that value is. Okay, so -infinity to -2, you can see it's undefined from -1, 0, and 1. So it stops at -2 and then it picks back up at +2, and those are both defined points. So -infinity to -2, bracket, union, +2 to infinity, because it skipped those numbers on the inside, as you could see on the table. Okay, so that is that problem. We can also do composition graphing. So I can make this, oops, gonna color code this one in blue. I don't know why I can't make a straight line. Okay, and then I'm gonna make the other one in green. It's gonna come out a little wonky, it's okay. You get the idea, okay? So the g of x graph is gonna be the green one, and the f of x graph is gonna be the blue one, okay? So they want us to find g composed with f, so we can rewrite that as g of f of -2. Okay, so remember that everything inside the parentheses is usually x, right? So this is usually f of x. So they're telling you that x is -2. So you're going to go to -2 on the coordinate plane, and the letter in front of the -2 is an f. So you're going to go to the f graph. So after you hit it, when you touch it, you're going to see what the y value is. Okay, so when x is -2, your y value is 1. So I can rewrite this as g of 1. Okay, so f of -2 is 1. And then you do it again. So x now is 1. So you're going to go to where x is 1 on the graph. And the letter in front of the 1 is a g. So this time you're going to go to the g graph. So you're going to go up. And then when you touch it, the y value there is 2. So your final answer is 2. Okay, let's try another one. F of g of 2. So you start with the inside. So you're going to do g of 2 first. So you go to where x equals 2. And then you go up to the green, which is the g graph. And the y value there is 3. So you're going to rewrite this as f of 3. And then you're going to find f of 3. So you're going to go to x equals 3. But notice that now the letter in front is f. So you're going to go down to the f graph. And the y value there is -4. And that's the final answer. Oops. Okay, let's try another one. G of 3. So you start with the inside, which is g of 3. So go to x equals 3. And then go to the g graph. And that y value is at 2. So now we have g of 2. This one actually is both g's, so you're not going to look at f at all. So you're going to go to 2, and you're going to go back to the g graph, and that y value is at positive 3. Okay, now let's try f composed with f composed with g, or we can rewrite that as f of g of 1. Okay, and starting with the inside always, you're going to find g of 1. So you go to x equals 1 and go up to the g of x graph, and that's at y equals 2. So we'll rewrite this as f of 2. And then we're going to do it again. So now x is 2, but notice that in front of the 2 we have f. So you're going to go to the f graph this time. So go to find x equals 2, and then find the f graph, and that y value is at negative 3. So now we have f of negative 3, and then you're going to do it one more time. So you find x equals negative 3 on the graph, which is here. Find the f value, and that's at positive 2. So the final answer is positive 2. Okay. That's how you can do it on a graph. Let's talk about decomposition. So decomposition is basically the opposite of composition. So if composition is putting one function inside the other, decomposition is taking them apart, basically. Okay, so let's say I have f of x in here and then g of x on the inside. So I'm trying to figure out what was plugged in as g of x that was plugged into f of x that gave me h of x. Okay, so how did I get x plus 1 squared minus 3 times x plus 1 plus 4? So you can see that easily that in the parentheses we plugged in x plus 1. So that could be the value of g of x. And if that is what we plugged in, then the original function would be x squared minus 3x plus 4. Because remember that g of x is where you plug into the x values. So that's how we could get this. Okay, so it's just basically you're taking them apart. So this one was pretty easy to see because it had the parentheses. This one has no parentheses, so there's going to be a few different options here. So let's talk about two different options that we can have. If you take out the whole thing, you can have g of x, x cubed plus 1, and then f of x could just be the square root of x, right? Because if you plug g of x into x, you would get the square root of x cubed plus 1, which is what we started with. Another option that we could have done as well is make g of x just x cubed, and then f of x could be the square root of x plus 1. Okay, because if you plug x cubed into x, then that's how you can end up with x cubed plus 1, because you plug in and replace the x with whatever g of x is equal to. Okay, so those are two options. There might be more, but yeah, so it just depends what the question is. Okay, moving on to tables. So you can also do composition using a table. So we have f of x in the first table and g of x on the second table, and they want us to do composition. So f composed with g, or f of g of 36. So you start with the inside. So remember, the inside tells you what x is, and then it tells you what table to look at. So this is the g table. X is 36, and when x is 36, your y is 6. Okay, so we're going to rewrite this as f of 6. And then you do it again. So now x is 6, but this time for the f table. So I'm going to go to the f table where x equals 6 and y is 21. And 21 is the final answer. Okay, let's do it again. Now we have g of 16. So this time we're not even going to look at the blue table. Okay, so go to where x is 16, you get y equals 4. And now you got g of 4, so when x is 4, y is 2. And this again, you're only looking at the green table. Okay, let's do g of f of 4. So you're going to go to f of 4. So on the f table, when x is 4, y is 1. So now you have g of 1. So on the green table, when x is 1, y is positive 1. Okay, last one, f of 4. You go to where x equals 4, you get a positive 1. And then stay on the f table and go to where f is 1. When x is 1, y is negative 14. Okay, so you get 21, 2, 1, and negative 14. So it's the same thing as doing it on the graph. So let's practice the graph one some more. So we have h of f of 3. So you start with the inside, go to where x equals 3. You're going to go down to the blue line, and the y value is negative 4. So now you have h of negative 4. That's the new x value. So you go to where x is negative 4, and you're going to go up to the red line, which is that positive 5. Okay, f of g of 4. You start with the inside, find g of 4. Go to where x is 4, go to the green, you see that y is 2. So now you have f of 2. Do it again, go to where x equals 2. Now you're going down to the blue, so the final answer is negative 3. Okay, let's do another one, f of negative 4. Go to where x is negative 4, go down to the blue, your y value is at negative 5. Stay on the blue line, go to x is negative 5, and now y is negative 6. Okay, g of 1. You go to g of 1, when x is 1, your y value is at 0. And then when your x is at 0, your y value is at 2. Okay, g of h of 0. When h is at 0, your y value is at 5. And when g is at 5, you're at 0. Okay, 5, negative 3, negative 6, 2, and 0 are those final answers. Let's practice some algebraic compositions again. So we just did graph, we did table, and now let's do it algebraically. So here we have 4 functions. We have f of x, g of x, h of x, and now we're also going to have j of x. Okay, so the first one, f of g of 3, f of g of 3. So remember, x is your 3 is your x value for the g graph. So you're going to go to g, and when you see an x, you're going to plug in a 3. So you're going to have 3 times 3 minus 2. Okay, and 3 times 3 is 9. 9 minus 2 is 7. Okay, so now you have f of 7, which is your new x value that is going to go into f. So in here, you're going to put a 7. So 2 times 7 squared. Okay, 7 squared is 49. And then 2 times 49 is 98. So that's the final answer there. Now let's do h of j of 12. So we have h of j of 12. So you're going to do 6 over 12 because you plug the x into j. And 6 over 12 reduces to 1/2. So now you're going to put that 1/2 into the x value of h. So in here, you're going to put in a 1/2. So you're going to do 3 minus 4 times 1/2. Okay. And 4 times 1/2 is 2, and 3 minus 2 is 1. Okay, so remember, when you have a number in the parentheses, you're going to get a number answer. Okay, for these two, and we have an x, we're going to get an equation answer. All right, so let's do g of h of x. So I'm going to plug h of x into g. So that'll be g, and then h of x, which is 3 minus 4x. And I'm going to put that into the x's of g. So that's going to be 3 times 3 minus 4x minus 2. Okay, and then you distribute. So you get 9 minus 12x minus 2. And then you combine your like terms. So you get negative 12x. And then 9 minus 2 is positive 7. Okay, so your final answer is negative 12x plus 7. All right, now let's do h of g of x. Okay, so we have h of g of x. You put g of x into the parentheses, which is 3x minus 2. And you're going to put that into every x of h. So h is 3 minus 4x, but instead of x, you're going to put 3x minus 2. You're going to distribute the negative 4. You get 3 minus 12x plus 8. Combine the like terms. You get negative 12x plus 11. Okay, last problem. Sally's salesperson sells shoes part-time at Super Shoes in the South Street Mall. She earned a 2% commission on total sales over $5,000, which is paid as a bonus at the end of the year. Let her total sales be represented by x. So f of x equals x minus 5,000, and g of x equals 0.02 times x. Which composition of functions would calculate her bonus at the end of the year? F of g of x or g of f of x? Explain your reasoning. Okay, so basically you got to understand that she doesn't get any extra money until she sells $5,000, right? So if she sells up to $5,000, she makes no extra money. That's just the minimum. Okay, but anything over $5,000, she's going to make a 2% bonus on. Okay, so let's say she sells like, I don't know, $12,000 worth of shoes, right? So this part she's getting a 2% bonus on, but not this part. This is the bare minimum that she is expected to meet. Okay, so in order to figure out what is going to have the 2% commission, first you got to figure out how much did she sell, subtract it from the 5,000, so we can get rid of this because this is not going to have the bonus. And after you figure out the value of this, then you're going to apply the 2%. So the first thing you need to figure out is how much money is over the 5,000. And then you're going to apply the 2%. So for that reason, the final answer would have to be g of f of x. Okay, because first you have to subtract. Okay, you have to subtract the $5,000 first. And then you're going to add the percentage. And we just converted the 2% to 0.02 because you cannot have percents in an equation. Okay, so let's say Sally sold $91.72 worth of shoes this year. Use composition of functions to calculate her bonus. So we said that we're going to do g of f of x. But now your x value is $91.72 because that's how much she sold. So you're going to put $91.72 into f. So $91.72 minus 5,000. Okay, 91 minus 91.72 minus 5,000 is 41.72. Okay, so now we're going to find g of 41.72, which is 0.02 times 41.72. Okay, so 4172 times 0.2, and we get $83.44. Which, if you ask me, it's pretty unfair. She's selling almost double of what she's expected to sell, and she's only making 83 bucks. Like, she can barely buy a pair of shoes at her own shoe store, but whatever. Um, so yes, so this is composition of functions. I hope that you understand how to do this both graphically on the table and algebraically. And I'll see you at the next video. Bye.